Hello, PreCalculus. Welcome to your weekend notes. These aren't going to be too long. That's the good news. But we do have some notes. We're going to talk about continuity and, more importantly, types of discontinuity. So for a continuous function, oh, by the way, we are getting textbooks on Monday, just so you know. So if you've been wanting extra problems to do at home or a textbook to look through to help you out, you will be getting those Monday in class. All right, the graph of a continuous function. So the graph has no breaks. Holes or gaps. All right, so if you think of the functions that we learned last year in Algebra 2, well, there's linear functions that we really learned in Algebra 1. That's a line. That has no breaks, no holes, no gaps. There's the quadratic function, right? Parabolas, no holes, no breaks, no gaps. There's the cubic function, no holes, no breaks, no gaps. There's variations of these when we start talking about polynomials. They have this basic shape, but they do funky things. We're going to learn that in a little bit. Let's see. Next one was rational function. What did that thing look like? Remember that was our whoosh whoosh graph, right? This has a break and a gap in it. It's got an asymptotic break there, just like this guy down here. And it's got an asymptote there. And so that is not a continuous graph. So this one, not continuous. Continuous, 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 not continuous. And then we also learned about exponential graphs. Those are continuous. It has an asymptote, but the asymptote doesn't break up the function. And then we learned about logarithmic functions. Again, it has an asymptote, but it doesn't break up the function. So these guys are also continuous. So the only one that we know of so far that we've studied that is not continuous is a rational function, except for piecewise, right? Then this looked kind of familiar after what we did on our last quiz. This is a piecewise function. They can also be discontinuous. So what you're more familiar with is a continuous graph. We know it's continuous because I can start drawing it and finish drawing it without picking up my pen, right? I can start drawing it and end drawing it without picking up the pen. If I have to whoosh and then whoosh, two different pen strokes, that's it's got a point of discontinuity in there. All right, so speaking of points of discontinuity, we have three different types of discontinuity we're going to talk about in PreCalculus. The first one is called an infinite discontinuity. We call that because on either side of the continuity, our graph is going either to positive infinity or down to negative infinity. So since it's going to infinity at that point, it is an infinite discontinuity. The second type, like we saw in piecewise functions, are called jump discontinuities. I'm going to draw my graph, I'm going to stop, I'm going to jump and draw another piece of the graph. And the last type of discontinuity, sorry, I'm getting a call there. Last type of discontinuity we're going to talk about is a removable discontinuity. And we saw those a little bit. Sometimes our rational functions have holes in them as well, right? And if you have a hole, that's called a removable discontinuity. In other words, it's continuous everywhere except for that little hole, and that's a removable discontinuity, like I removed that one point from the line. All right, so let's see if we can look at some graphs and identify what we have going on. So what do you think is the type of discontinuity for A? Hopefully saying, well, that's a jump discontinuity. And that is at, let's see, 1, 2, 3, 4, 5, 6. X equals 6. So when x is 6, we have a jump discontinuity. Learning targets are being able to identify if we have a continuous function or if we have a discontinuous function, what type is the discontinuity and where does it occur? All right, what kind of do we have for B? There's a hole in that graph, so this is going to be a removable discontinuity. And this is at x equals, let's see, -1, -2, -3, -3. And our last one here, what does that one look like? Looks like an asymptote to me. On either side of that asymptote, we're either going to negative or positive infinity. So this is going to be an infinite discontinuity. And that is at x equals 2. All right. Go ahead and pause your video. Notice that these graphs are fun graphs. I actually pulled this from our calculus curriculum. So you're going to see this at the beginning of next year if you stick with calculus. And these graphs have all 3 types of discontinuities in them. So I want you to list all of the discontinuities for each of these graphs and tell me where they occur. So go ahead and pause your video, see if you can find the 3 different discontinuities for each of these graphs, and then tell me where do they occur. All right, if you're coming back, I assume you've paused your videos, you've got some answers you want to check. All right, for A, we've got a removable discontinuity. And that is at, let's see, that's x equals negative 5. When x is negative 3, we've got an asymptote, so that's an infinite discontinuity. And that's at x equals negative 3. And then coming up here, I have to pick up my pen and jump up here to start drawing again. So I have a jump discontinuity. And that is at x equals 2. Moving over to B. First, I have a jump discontinuity here at negative 4. At negative 3, I've got a removable. It's okay. Sometimes you'll see that it's defined elsewhere. That's okay. It's still a removable discontinuity. Sometimes this won't be defined at all, and you just have a plain old hole. Either way, it's called a removable discontinuity. And that is at x equals negative 3. And then I also see this asymptote here. Notice we're going down to negative infinity. So I have an infinite discontinuity. To the right side, but it's at x equals 4. Notice this graph doesn't even make it all the way over to 4. So we can't say it's infinity on both sides. This is just a gap in that graph. We don't really have a name for that in PreCalculus, so we're just going to leave it as an infinite discontinuity at x equals 4. So this is what we'll be doing on Monday. We'll do some sort of activity where we try to label it as a jump or an infinite or a infinite discontinuity. We're also going to get our textbooks. And then on Tuesday, we're going to do a little bit of end behavior. You've seen that before. So we're going to do some end behavior on Tuesday. Wednesday is going to be your review, and then Thursday is your test. Have a great weekend, guys.